Ding. We're good. Going? All right. When we film something, we try to either do a demo like this in the class where it's reasonably well lit so you can see, or we kind of go that way. The first rule of filming is to pay attention to which direction or which orientation your camera is going and make the best choice for the subject matter you see. Okay? Tall if it needs to be tall, wide if it needs to be wide. And the second rule is don't film where there's a great deal of distraction in the background, because even though it doesn't seem like much because you filter it out at the time when you go back to play it later, it's just the, you know. So we have to be really careful we don't film over there by the window. There's people walking by all the time. It is horrifically distracting to later watch something where there's things going on in the background you don't want. Okay? We have a project coming up where you are going to make kind of a little notepad thing. And anytime we can, I realize this is upside down for you guys, but it'll be okay. Eventually it'll be right side up. Anytime that we can do a physical object to help you learn a grid or a measuring or math thing, it's more helpful because you kind of can pick it up and look at it, turn around and see how this works. You know, it's better than just talking about what it might be like. So this stack I think is a little thicker than what it's going to end up being, but it'll be similar to this little pad of things, and we're going to do a little thing with perfing so that it's easier to tear them off and fasten them together. And I just eyeballed this and tore it off, so it's a sample kind of, not exactly what we're going to make, but similar. And it'll go like this, and it'll whip around like so, and come around like this, come around like this, and there'll be room up in the top that you can stick a pen or a pencil in it, and it'll come down like this. And the cover will be heavy, so it sort of works like a matchbook. You're going to end up with something where this piece tucks inside of there, it's like that. Okay? Get the general idea. It'll sort of be like a book of matches with a little tab on the side. That's the most similar description that I can give. And the first thing we have to figure out is using 8.5 by 11 or letter size paper. 8.5 by 11, which is the same thing as letter. We need to figure out how we can divide that up. It's going to make pieces, you know, that are sort of similar to this. Okay? We need equal sections. We need as close to square. When I say equal sections, that also means no waste and not too small. Okay? Too small is like 2.5 inches. Okay? 2.5 inches is like the beginning of too small to be any good. Okay? Now, those of you who are filming obviously can't write anything down, but you know you can get a photocopy of notes from your buddies, or if you need to, or whatever. So they're going to be as close to square in shape as we can figure out. Good, stop. Start again. It's all right.
Not record video. There is not enough video.
Interesting. Okay. Well, never mind. We'll keep going on that one. We'll be all right. I need to clear some stuff off again, of course. Okay. So this is our general idea. Okay. Equal sections, close to square, no waste, not too small. Figure that out, and then that will give us. It's going to be similar to what I got here. This is just some scratch paper, just grabbing envelopes, so it'll be similar to this. We are going to make this little cover. The cover will be one long rectangle, and that will be on paper that is heavier weight, right? The cover will be heavy. Cover will be heavy. And so we have to figure out exactly how big is that, and exactly where are all the folds going to be in it. Because we're going to have to come along and score where the folds are. A score is like a crease that you make first with a tool so that then you can fold it there and it folds better. And you'll see how that works. And then we have to be sure that we don't have so many pieces in the stack that the stapler won't go through it. Right? We're going to have to test it for, we have heavy-duty staplers around here. You guys already met the saddle stitch stapler last week, right? The saddle stitch one, that term should be in your notes. Saddle stitch was a flavor of stapler that we used for the booklet. Okay. But we have heavy-duty staplers, and we have long shank staplers and different kinds of staplers for different purposes. And So we want enough pieces of paper in the stack that is useful, but we don't want it to be so thick that we can't get the stapler through it, okay? And so it's going to be somewhere between 1/8 of an inch and 1/4 of an inch thick for the stack. We're going to have to figure out what is that, okay? Because it has to go through all of these sheets and through the cover to hold the thing together. We have alternatives, but we're going to use this as a way to figure out what are those parameters, how does this all work. Because things have dimensions of width, they have dimensions of height, but they also have depth and thickness. And those are math properties. And they also have characteristics or properties of the materials that some things work for some things and other things just don't. You know, you have to figure that out. So this will have, as you can see, it's the sections that wrap around it are bigger than the tablet, but then there's a little part at the end. So I'm going to wrap this around one more time so you kind of get the sense of how this goes. You'll have a little tablet here, and before it becomes a tablet, it'll get perforations there, so it'll be easy to tear off the little sheets. We have a perfor, it'll show you how to use that. And it'll go on here and get stapled carefully so that there's a little lip in here, kind of like on a book of matches, and it'll go around here, and around here, and around here, and around here, and then this piece will tuck in there when it's done. But we need to leave enough slack up in here that if you have a really small pen or pencil, you can stick it in there and it'll fit above the top of the paper so it stays inside. Okay? The general idea. Now, so we need to figure out how big are all those dimensions. How big is it? Now we have another variable. Okay. I think about another issue. Okay? Paper folds better with the grain. Now, what is grain? Okay, what is paper grain? I want you to imagine for a little bit that we're making paper. We're in a factory where paper is made. I have to draw it sort of out of proportion because it'll never ever be right if I don't. Okay. Down here, there is a giant machine like a blender where all the pulp and all that stuff goes into to make the paper. Okay? And then, every so often, it dumps out on here. And this thing is a conveyor belt. It is actually called a Ford-Renier screen, and it's named after the people who invented it, the Ford-Renier brothers. But it's a conveyor belt made out of something not too different from window screen. Okay? Heavy duty, but like window screen. And where I've drawn here to here, and it's about 5 inches, that's actually like a mile in reality in factory. Okay. And the goop goes along here, and as it's traveling, it's kind of getting shaped up, and all the liquid is dripping out of it. Okay? And eventually, it's going to become flat, and it will go through rollers and calendar things that will press it and make it come flat. And eventually, it will come out here and become a giant roll of paper that's about the size of a Volkswagen when it's all done. Okay? But as it's going along here, the fiber in the paper has length to it, the cellulosic fiber, or depending on what it's made out of. And as it goes like this, the fibers get joggled and they kind of line up in the direction they're moving. Okay? They're like longer than they are wide, and they line up in the direction that they're moving. So eventually, by the time it's all cooked and done, pressed flat, there are little microfibers in the paper that have been lining up, traveling in the direction that the conveyor belt went. Okay? And that is grain in paper. So that later on, when you take the paper and you cut it up into smaller pieces in a commercial way, and we usually buy it in what are called reams, those paper-wrapped packages of either 500 or 250 sheets depending. Those are called reams. R-E-A-M is a ream. That's a package of paper wrapped up from the vendor, you know. A ream of paper has grain direction on it. On the outside on the label, you can tell which way is the grain direction. And we have to be sure that when we do, especially anything that's heavy like cover stock, we're folding it with the grain whenever possible. With the grain, we get a better, cleaner fold. It's less likely to get broken and icky, right? Okay, so normally, the paper when it comes out of a package is what's called grain long. Grain long. Even though you can't see it, you can feel it. We're going to go in there and fold up some paper in a little bit, and you'll get what I mean. Okay? Grain long. So that means that when we make the covers for these little things, we need to run them effectively this way on the paper so that all the places where we score it and fold it where it wraps around are all going with the grain of the paper. You see that? Got it? Okay. So you can turn that off for now, thank you.